Morning, this is Vasu Sharma. I'm an undergraduate student of Thapa University, India. Today, I'm going to talk about an innovative internal combustion engine. We all know internal combustion engines that are being used in almost all kind of locomotives, that are cars, buses, trucks, and almost all the locomotives. So it's a very important invention, but it has a serious drawback, that is it is able to utilize only 20% of the fuel energy to useful work, which means 80% of the energy is lost. So there's a huge scope of increase in efficiency or improvising the technology. And today I am here with the innovative design of internal combustion engine, which can increase the efficiency from 20% to 50 to 60%. The technology is at design stage. That means we have the theoretical data, we have the theoretical model, and everything on the paper that is sufficient to justify it, to justify its efficiency or its increment in efficiency. But we lack working prototype, and we want to participate in green postcode challenge so that we have enough funds to get the technology patented, make the working prototype, and get at least 10 working engines, sample engines, so that we can present it to the automobile manufacturers. Now, what our design does is that it reduces the frictional losses, a component of frictional losses that is generated due to angle subtended by the connecting rod with the piston. I have a diagram with me. If the connecting rod does not subtend an angle with the piston, there is tremendous decrease in the frictional forces exerted by the piston rings on the chamber. I have a technology with which the piston can convert its translatory motion or translation to rotatory motion without subtending an angle, that is, without connecting rod subtended an angle with the piston. This is the diagram. The diagram is attached with the application tool. What happens in this is, when the piston moves down, the gear 1, it's a basically system of gears. When the piston moves down, this rod moves down, and with the help of this teeth and this gear with teeth on half of its circumference, gains the translatory energy and converts it into the rotatory energy. That means when this moves down, the gear 1 rotates, and when it has to go upwards, that is reverse its motion, this gear 2 helps it in bringing it back to the original position, that is the top dead center. So basically what we are doing is that we are coming up with a technology in which the connecting rod remains perpendicular to the piston throughout the cycle. So the majority of the frictional forces are eliminated. Let me talk about some of the stats. Total frictional losses in an engine that's in an engine those are being used engines those are being used these days, 20 to 25% of the energy is lost as frictional losses, and out of this frictional losses, 80% are the frictional losses generated due to the angle subtended by the connecting rod. That is, when the connecting rod is not perpendicular to the piston, the increase in frictional forces magnify the frictional losses, and this component of the frictional losses is 80% of the total frictional losses. Now, we are not done with that. Along with this, we are targeting reducing exhaust gas temperature. We are directly utilizing the low pressure of the gases to useful work. What we are doing is we have a technology with which we can utilize the low pressure to produce useful work without compromising with the mean effective pressure. What happens is, if we try to utilize the low pressure of the gases, what happens is the mean effective pressure or the total power output of the engine reduces, and that is not good for performance of the engine, because no one would like an engine whose net power output is low. So an engine with such a design which increases the efficiency simultaneously compromising with the mean effective pressure is not at all a good design. We have a technology with which we can utilize those low pressures to get useful work without compromising with the mean effective pressure. How do we do that is, we combust gases in two cylinders simultaneously. This is the diagram. Basically, this innovative combustion cycle is best suited for 6-cylinder engines, but a part of it is sufficient to understand this. What happens is, when the gases, let's come here. Here the gases are air fuel mixture is compressed and combusted. Now the piston is ready to move downward. It's in the expansion stroke. Now what happens in the next step is, here the pressure of the burned mixture is very low. So what do? Is we combust the air fuel mixture in the corresponding or the adjacent in the adjacent chamber. What's the use of burning fuel simultaneously in two cylinders is, when the pressure is low, this high pressure combusted air fuel mixture supports this piston, so we are able to utilize this low pressure without compromising with the mean effective pressure. So this is basically a innovation in this field of technology. There are many products that are trying to capture the market, but none of the innovative combustion engine has made its way to the market. But this engine has a huge scope of becoming a success in the market. The main reason is that all the parts of the engine that are being used in this innovative technology or this innovative design are same as those being used these days. So when we have to produce these engines on large scale, we do not need new machinery, because if we change all the parts of the engine, we need new machinery to produce those parts. So the investment of producing those engines is very high. But that's not the case with this engine or this design, because we are replacing just the crankshaft and all other parts are same. Also, when we are using the same parts, there is very less probability of the failure of the engine, and there are very less questions on the durability of the engine, because all the parts being used are same as those being used presently. So we know how durable those parts are and what's the life of the parts of those parts of the engine. So this engine is not only innovative, not only it tremendously increases the efficiency, but also is practical and has the potential to capture the market instantly. It's a product which can be brought to the market within 2 years. Now, we are basically a group of students and my father who finances us. Kind of finances are very low, that's sufficient for small level research. So basically what do we want is, we want a financer, or we want funds so that we can spend them on our research, on making a working prototype, on getting a technology patented. Also, we want an interested automobile manufacturer, because manufacturing engines on large scale without collaborating with an automobile manufacturer is just a waste of time and is an unrealistic project. So basically we have everything. We have the complete business plan, we have the design of the technology, we have idea of how to get it started, how to approach the automobile manufacturers, what all do we need before approaching an automobile manufacturer who would be interested in our technology, what kind of stats we need, uh, what kind of funds we need, estimating the funds, how much money is needed approximately. If we calculate it in terms of US dollars, it's approximately dollar 200,000, that is 2 lakh dollars, that we need to get the technology patented, make a working prototype, as well as make sample engines. And afterwards we can approach automobile manufacturers, and those interested manufacturers will produce this will then produce these engines on large scale and fit them in their vehicles. And one more thing I forgot about, one more feature of this technology is that the basic shape and size of this engine is same as those being used presently. So one more big advantage of this technology is that we don't need to adjust everything in the hood of the car to adjust these engines. It can be simply replaced by the existing engine, that is, we can simply take out the existing engine and fit these engines in place of them. Whereas most of the innovative engines come up with so weird designs that we need to change almost everything in the hood of the car to adjust them into, so that's make it a bit expensive job to produce vehicles fitted with that, because we need to change the design of the vehicle completely to fit those engines into those vehicles. So basically this was that. Hope that the jury of the postcode green postcode lottery challenge likes this technology, because this is the technology that is not only helping the consumers to reduce their fuel expenditure with a nominal increase in the price of the engine, that is approximately 10%. Also it is environment friendly, because if we increase the efficiency 2 times than the engines being used presently, that means we are reducing the carbon dioxide emissions to 50%. That means we are generating half the amount of carbon dioxide those being produced presently. And we all know internal combustion engines are being used so widely and its number is so large all over the world, that the carbon dioxide emissions from these engines contribute for a very large part of the total carbon dioxide emissions of the world. So it's basically consumer friendly as well as environment friendly, with an innovative technology, with a practical design, with a full-fledged business plan in which we have very accurate to uh, our best knowledge, that is with the very accurate stats, with very accurate expenditure estimations, cost estimations to our best knowledge. So hope for the best and thank you for giving your time.